Policy gradient methods. Policy gradient methods in reinforcement learning. AI Advanced Level. Introduction. In reinforcement learning, agents aim to learn the best actions to maximize rewards. Earlier methods like Q-learning and DQN focus on learning value functions. However, these methods can struggle with continuous action spaces, complex policies, stochastic environments. To address this, we use policy gradient methods. These methods directly learn the policy decision-making strategy instead of estimating value functions. What are policy gradient methods? Policy gradient methods are reinforcement learning algorithms that optimize the agent's policy directly using gradient ascent. In simple terms, policy gradient equals learning the best actions directly. Example concept. State means policy means action means reward means update policy. What is a policy? A policy, pi, defines how an agent chooses actions based on the current state. Example concept. Pi, a(s) equals probability of taking action in state S. The goal is to learn an optimal policy that maximizes rewards. Why policy gradient methods are important? Policy gradient methods are important because they handle continuous action spaces, learn stochastic policies, work well in complex environments, directly optimize behavior, are used in advanced RL systems. Example concept. Direct policy learning means better decision-making. Key idea behind policy gradient. Instead of learning Q values, Q learning means value-based. Policy gradient learns. Policy means best action distribution. It adjusts the policy parameters to increase expected reward. Policy gradient objective. The goal is to maximize expected reward. J, theta, equals E, pi, theta, R, J, theta, equals E, pi, theta, R, where theta means policy parameters, R means reward. Policy gradient update rule. The policy is updated using gradients. Nabla, theta, J, theta, equals E, nabla, theta, log, pi, theta, A, divides, S, dot operator, R, nabla, theta, J, theta, equals E, nabla, theta, log pi, theta, A divides S, dot operator R. This means increase probability of good actions, decrease probability of bad actions. How policy gradient works. Workflow. Initialize policy. Down pointing arrow. Observe state. Down pointing arrow. Sample action from policy. Down pointing arrow. Execute action. Down pointing arrow. Receive reward. Down pointing arrow. Update policy using gradient. Down pointing arrow. Repeat. Stochastic policies. Policy gradient methods often use probabilistic policies. Example. Action probabilities. Move left means 0.2. Move right means 0.8. This allows exploration naturally. Reinforce algorithm. One of the simplest policy gradient methods. Example concept. Episode means collect rewards means update policy. Steps. Run episode. Collect rewards. Update policy based on total reward. Actor-critic methods. Combines policy gradient with value estimation. Actor. Learns policy. Critic. Evaluates actions. Example concept. Actor means action. Critic means feedback. Advantages of policy gradient methods. Advantages include handles continuous action spaces, learns stochastic policies, more flexible than value-based methods, works well in complex environments. Example concept. Direct learning means smoother policies. Challenges of policy gradient methods. Challenges include high variance in updates, slower convergence, requires careful tuning. Sample inefficiency. Policy gradient versus Q-learning. Q-learning learns value function, discrete actions. Policy gradient learns policy directly, supports continuous actions. Policy gradient versus DQN. DQN value-based uses neural network for Q values. Policy gradient policy-based directly optimizes action probabilities. Example Python code. Conceptual. Import torch. log_prob equals torch, tensor. 0.5. Reward equals torch, tensor. 10.0. Loss equals log_prob reward. Loss, backward. Applications of policy gradient methods. Robotics. Continuous control tasks. Autonomous driving. Smooth decision making. Game AI. Complex strategy games. Finance. Trading strategies. Control systems. Real-time optimization. Advanced policy gradient methods. Proximal policy optimization. PPO. Stable and efficient. Trust region policy optimization. TRPO. Ensures safe updates. Advantage actor-critic. A2C. Improves learning efficiency. Future of policy gradient methods. Future trends include combining with deep learning, multi-agent systems, improved sample efficiency, real-world robotics applications. Example concept. Advanced policies means intelligent control systems. Concepts learned from policy gradient. Understanding policy gradient helps learners understand. Checkmark how policies are optimized directly. Checkmark how gradients guide learning. Checkmark how stochastic decision-making works. Checkmark how RL handles continuous actions. Checkmark how advanced RL systems are built. Simple definition. Policy gradient methods. Reinforcement learning algorithms that directly optimize the policy using gradient-based techniques. Final summary. Policy gradient methods are a powerful class of reinforcement learning algorithms that directly learn optimal policies. They are especially useful for continuous action spaces and complex environments. By optimizing the policy using gradients, these methods enable flexible and effective decision-making. They form the foundation for advanced algorithms like PPO and actor-critic models. Understanding policy gradient methods is essential for building advanced reinforcement learning and control systems.